Welcome to Brain Vision.
So here we are told to describe electron affinity. So electron affinity, like the name suggests, affinity means the love for something. So when you talk about electron affinity, it means the love for electron. That is the ability of an atom to receive electron. So how does this um, vary across the periodic table? So, well, electron affinity is described in terms of energy. So, for example, if you have a chlorine atom that is gas, and then you're trying to add an electron to it to form the chlorine ion, which is the gas, it has an electron affinity value in units of energy. And the unit could be kilojoule per mole, calories, or any other unit of energy. So how do the electron affinity vary across the periodic table? So the electron affinity goes in the same direction as the atomic size. So as the atom becomes smaller, the electron affinity also increases because then the effective nuclear charge that is felt by the added electron will increase. So for example, if you go from, so let's describe the across period, left to right. When you go from left to right across the period on the periodic table, the size of the atom decreases. It decreases generally. So that decrease in size of the atom will lead to an increase in the ability of the atom to accept electron. So electron affinity increases across the periodic table from left to right. Now, down the group, what happened? When you go down the group from top to bottom, new shell is being added, and that will lead to an increase in the size of the atom. And this increase in size will lead to a decrease in the effective nuclear charge because of screening, and that will lead to a decrease in the ability of the atom to accept electron. So the electron affinity for the atom will decrease down the group, so it decreases down the group.